Hello everyone, myself Vinay Kumar M. I am actually pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in this particular video, we will see the further concepts which are there in this particular chapter. So coming to the next concept in this particular chapter, that is atomic mass. So what do you mean by atomic mass? It is just the mass of an individual element. So for example, if you are taking oxygen as your element or carbon as your element, the individual carbon atom or the individual oxygen atom, how much mass that particular atom has is the atomic mass of that particular element. So for example, if you are considering carbon, then this particular carbon is made up of so many carbon atoms. So the mass of individual atoms of this particular carbon will be the atomic mass of this particular carbon. Or if you consider oxygen, then this particular oxygen will be containing oxygen atoms in it. So the mass of this particular individual atom of this particular oxygen will be the atomic mass of this particular oxygen. So this is just a rough idea of understanding atomic mass. But how to calculate this particular atomic mass? Because we know each and every element has different atomic mass, because carbon has different atomic mass, oxygen has different atomic mass, hydrogen has different atomic mass, sodium has different atomic mass, even phosphorus has different atomic mass. So every atoms or every elements are made up of their respective atoms, and all these atoms have different mass. So how to find out this particular mass of each and every element which is there in the periodic table? So to calculate that, we actually use some kind of relative mass techniques. So how this particular relative mass technique works? So for example, if you consider carbon monoxide gas, so carbon monoxide is actually made up of carbon and oxygen. So one atom of carbon combines with one atom of oxygen. So this actually forms carbon monoxide. Here carbon to oxygen mass, if you actually calculate, so experimentally it was calculated that 3 gram of carbon mixed with 4 gram of oxygen. So when 3 gram of carbon mixed with 4 gram of oxygen, then you will get carbon monoxide. That means if you are taking 7 gram of carbon monoxide, in that 7 gram of carbon monoxide, 3 gram will be carbon and 4 gram will be oxygen. So this was experimentally calculated. So based on this, you can come to a conclusion that if the mass of one carbon atom is 1, then mass of oxygen atom will be 1.33 AMU, that is atomic mass unit. So AMU was the unit which was actually used in the olden days. Now we can use this particular symbol, just U. So this is actually the symbol recommended by IUPAC. So this U represents atomic mass unit, or it is also known as unified mass unit. So 1 AMU or 1 U, if you consider this as the mass of carbon, then 1.33 AMU will be the mass of oxygen. How? Because here we know that 3 gram of carbon is mixing with 4 gram of oxygen. When 3 gram of carbon is mixing with 4 gram of oxygen means, here if you consider this 3 as 1, then this 4 will be 1.33, because now you can just divide this 3 gram with 3. So when you actually divide this 3 gram with 3, you will get 1. Similarly, when you divide this particular 3 gram with 3, then you should divide this 4 gram also with 3, because you should follow the same rule for each of the element. So now if you are dividing this with 3, you should divide this with 3. So when you divide this particular 4 with 3, you will get 1.33. So now what is 1.33? 1.33 is the atomic mass unit of that oxygen compared with carbon. It is not the individual atomic mass unit of oxygen. You cannot just say 1.33 is the atomic mass unit of oxygen. 1.33 is the atomic mass unit compared with the carbon in carbon monoxide molecule. So this is how you actually compare the mass of carbon with the mass of oxygen in carbon monoxide. So this is actually a crude idea of relative mass. So this is how relative mass works. This particular method is actually known as relative mass technique. So here you are actually relating one particular mass with the mass of other element. So you are taking mass of one element and you are comparing that mass with the mass of other element. For example, if you have a fruit shop like this, so in a fruit shop, if a fruit vendor doesn't have any kind of mass scale, at that particular point, he will take one particular piece of a particular fruit and he will place on one side of that particular measurement scale. On the other side of that particular measurement scale, he will actually keep whatever fruits you are actually purchasing. He will fix the price of the fruits which are actually taken by customers based on the weight of this particular one piece of fruit which is actually keeping on the other side. So the weight of this particular one piece of fruit is on one side of the measurement scale, and the fruits which are actually consumed by the customers is there on the other side of the weighing scale. So he will actually balance the fruits taken by this particular consumers with the fruit piece which he has as his reference. So keeping that particular fruit piece as his reference, he will actually weigh the other particular fruits which are there in that particular fruit shop. So like this, when he doesn't have any kind of weighing scale or any kind of mass object to compare the weight of the fruits, then he actually uses his own technique by comparing mass of one particular fruit with the mass of other fruit. So like this, he actually calculates the weight of other fruits with the reference fruit. So this is how relative mass techniques work. Here also, we are comparing the mass of oxygen with respect to the mass of carbon which is there in carbon monoxide. But this is very crude idea. So that's why in the initial days they came up with oxygen atom. So in the olden days, scientists considered oxygen as the reference element because oxygen was abundantly available and also oxygen easily formed bond with most of the elements and compounds present on this particular planet Earth. So that's why scientists considered oxygen in the initial days, where they fixed the mass of this particular oxygen as 16. So the atomic mass unit was 16 AMU for this particular oxygen, and 1 by 16th of the mass of this particular oxygen was given as the individual mass of different elements present in the periodic table. One particular problem which was there in this particular oxygen is that when we take 1/16th mass of oxygen as the measurement scale to measure atomic mass of different elements, at this particular time 1 by 16th mass of oxygen. So this particular oxygen, 1/16th mass of oxygen, was not giving whole numbers for most of the elements in the periodic table. So later on there was a universally accepted atomic mass concept where there carbon was considered as an element. So carbon was fixed as 12 atomic mass unit. So the mass of this particular carbon was 12 atomic mass unit. This was fixed for carbon, and later on 1/12th of the mass of this particular carbon was considered to measure the mass of individual atom. So 1/12th mass of carbon 12, because C12 is an isotope of carbon where it contains 6 protons and 6 neutrons as its atomic mass number. So this particular C12 isotope has 12 AMU, that is 12 atomic mass unit as its mass, and this particular mass is divided by 12, and 1/12th mass of this particular carbon 12 isotope was used to measure the mass of other elements. For example, if we take hydrogen as an example, hydrogen has 1 atomic mass unit as its mass. How this one was actually calculated? So now 12 atomic mass unit is actually fixed for carbon. Now if you want to find out mass of this particular hydrogen, it was found to be 1 AMU. How this 1 AMU was calculated? 1/12th mass of this particular carbon was the mass of this particular hydrogen. experimentally it was proven that mass of hydrogen is actually 1/12 of the mass of carbon. So now 1 AMU means the mass of hydrogen is 1 AMU. So what do you mean by 1 AMU? 1 represents 1/12 of carbon 12 isotope. That means if you take carbon atom, this carbon atom is actually divided into 12 pieces. So let's imagine you cannot divide atom. First of all, you should remember that you cannot divide atom. Just for understanding the concept, I am using the term dividing an atom. So let's say we are taking one carbon atom and we are dividing that particular carbon atom into 12 pieces. So if you take individual piece among that particular 12 pieces, so what mass will be there? So here you should make equal pieces. So 12 equal pieces. So one piece, how much mass that particular one piece of carbon atom will be having, that much amount of mass will be there for hydrogen. That means here 1/12 of the mass of carbon is the mass of hydrogen. That is how you are actually referring to. So here you should remember 1/12 mass of carbon atom is equal to, so the 1/12 mass of carbon 12 isotope is equal to 1 atomic mass unit. So this particular 1 atomic mass unit is the mass of hydrogen atom, because the mass of hydrogen atom is 1/12 of the mass of carbon atom. So this is how they are actually using the scale of this particular carbon 12 isotope mass, and 1/12 of the mass of that particular carbon 12, they are actually naming it as 1 atomic mass unit, and that particular 1 atomic mass unit is next calculated as the mass unit for different elements as well. So now if you consider oxygen, for example, oxygen mass is 16 AMU. So if you consider oxygen atom, the mass of that particular oxygen atom is 16 atomic mass unit. So what do you mean by 16 atomic mass unit? That means here 16 divided by 12 mass of carbon 12 atom. So that is actually 16 into 1 AMU. So here you are multiplying this particular 1 by 12 into 16, and here you are multiplying 1 with 16. So 16 into 1/12 mass of carbon 12 atom is the mass of oxygen atom. So that means if you are considering carbon atom, the mass of carbon atom is 12, then the mass of oxygen atom will be 16. So to get 1 atomic mass unit, here you are actually dividing this 12 with 12. Here you are dividing 16 with 12. So that is how you are actually calculating. Oxygen has 16 AMU as its mass. So 16 AMU is the 16th times 1 by 12th mass of C12 atom. So this is how you should actually compare mass of different elements with 1/12th mass of carbon 12 atom or carbon 12 isotope. So this is actually the rule which is actually used to calculate the mass of individual atoms of different elements. So calculating atomic mass is very difficult task, because it is very small in size. It is having size in the range of 10 power minus 9 or 10 power minus 10. One atom is in that particular range. So to calculate mass of that much small particle is very difficult. Hence they came up with this particular concept where they assigned carbon 12 isotope atomic mass as 12, and that particular 12 was assigned based on how many protons and how many neutrons are actually there in that particular carbon 12 isotope. Based on that, this particular 12 was assigned, and similarly the other atomic mass unit was calculated, and that particular atomic mass unit is comparable with the number of protons and number of neutrons present in that particular element as well. So you will understand what you mean by number of protons, number of neutrons in a particular atom in your next chapters. So as of now, the mass of that particular carbon 12 isotope is kept as reference, and 1/12th mass of that particular carbon 12 is assigned as 1 atomic mass unit, and that particular 1 atomic mass unit is taken as 1/12th mass of carbon 12 isotope, and based on this particular calculation every element got their atomic mass units. So this is all there in this particular video. I have taught you how atomic mass unit is referred to 1/12th mass of carbon 12 isotope. The further concept which are there in this particular chapter will be explained in subsequent videos. So like this, if you want to learn more physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.